Alrighty, so welcome to the third lesson from the logic unit, 15C in the book. We have truth tables and logical equivalence. So as you can see here, logical equivalence is when two compound propositions have the same true-false column. So if we're going to work through this, we're going to see what is logically equivalent here. Now, if you remember from last time, true, true, false, false. Come on, there we go. True, false, true, false. True there. Okay, so this is just how we set it up. It's in your formula packet, but not too big a deal. True, 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 false, false, true, false, false. So, not P. This is the opposite of this. All you have to do is look at this and do the opposite. So we have false, false, true, come on, true. I'm having pen issues today. So, and then now we're looking at P. Remember what this means? And, P and Q. So we're looking at both these. They have to both be true. If they're both true, then this is true. Are they both true? Yes. Are they both true? No. Are they both true? No. And here, are they both true? Definitely not. So only the first one is true for this. Remember what this means? Or both. It could be or both. So if there's at least one true, okay, so the only one that's false is this one. The rest of these are true because it's this or both. Okay, so that's true. Remember what this means? Good, this is or, but not both. So here we have both, so it is actually false. Here, this is or and only one's true, so this is true. Here, this is or and only one's true, so this is true. Here, or, but neither is true, so it's false. Okay, so that's how we fill in the truth table for these compound propositions here. Alright, now let's move on and take a look. We want to show that these are logically equivalent. Okay? So go ahead and see if you can fill these in. And if you did it right, this column is going to match this column. Okay? Go ahead and stop right now and fill it in yourself. Okay, you're back. So you're going to check your work. Okay? So true, 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 false, false, true, false, false. P and Q, only this one's true. These are false. Right? F, so it really doesn't like that, does it? Okay, this is now, you're gonna mess it up. Alright, what? Whew, okay. True, 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 false, false, true, false, false. Okay, we set that up. Now, not P and Q. In other words, not this. So it's the opposite of this. So we have false, true, we have true, we have true. Okay? So this is the column that hopefully is going to match here. Okay, let's fill this in quickly. True, 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 false, false, true, false, false. Okay, not P is just the opposite of this. False, false, true, true. Not Q is the opposite of this. False, true, false, true. And then this is an or both. Or both. Nope. This is or, yeah, that'll work. This is or, yeah. This is or both. Hey, look, it's both. Bam. Now notice that this and this are the same. They are logically equivalent. Okay, that's what that means. False, true, true, true. False, true, true, true. logically equivalent. Moving on, tautology is another new word, a compound statement for which is true for all possibilities. So we want to show that this is a tautology. See if you can fill this in. Go ahead and stop and try to fill it in. Okay, so let's see how you did. We have true and false. Believe it or not, these aren't necessary. That's silly. Sorry, threw you for a loop there. True and false. This you only need 4 if you have 2 different. There's only one. Anyway, not a Q. In other words. Okay, so it's true. If it's not P, then this would be false. This is false. Not false would be true. So now it's either this or this. At least one's true. Yep. At least one's true. Yep. And that's it. Good. Good. Let's move on here. Logical contradiction. Wow, this is messed up. Let's see what I can do here. So, I'm having some issues with my pen today. A compound statement which is false for all possibilities. Kind of the opposite of a tautology. It's false for all possibilities. So see if you can fill this in. The hint is these columns are not necessary. Just these first 2. So you can stop and fill this in. Okay, so let's see how you did here. We have true and false. The opposite of true is false. The opposite of false is true. Now, if it's and, it has to be both. Are both true? Nope. Are both true? Nope. So, this is false for everything. So it's a logical contradiction. That's what that means. Okay? So I hope that you learned a thing or two, and we'll see you next time. Toodles.